Assalamu alaikum. My name is Dr. Saqib Iqbal. Welcome to lecture number 11 of software construction. Today we'll study about GUI programming in Java. Okay, before going on to today's lecture, I'm going to recap what we studied in the previous lecture. In the last lecture we talked about software design frameworks, and which are basically used to give you extra functionalities and which give you control on the functionalities. You don't have to write code for certain features. A framework can insert code for you, a framework can run some code for you, or it can provide you some libraries where you can choose code for a specific kind of tasks you want to put in your system. So we looked at some generic features of a framework, and then we looked at Java framework, which provide you with different APIs, libraries and applets. We saw that what kind of advantages a framework has got and which it offers. There are some certain features which you can use to make your system better, efficient, and you can also reduce the code size which you write in the system. You can simply call different features of framework, and they are appended during the execution time, and they provide you some functionalities which otherwise could take a lot of your time while you are writing them. In the framework you just import those features which are provided by the libraries, and you just write them, their call in just one line of code, and that feature automatically runs for you at the execution time. So today we're going to take further that Java framework, and we're going to talk about GUI frameworks and the GUI programming which you do in the frameworks in Java. And we will look at some programming concepts of GUI. GUI is basically graphical user interface, and it consists of different kind of graphical images which you use in your system, such as buttons, layouts, windows, and the arrows, or the menus, or the sub-menus and frames, and all those kind of visible features which you look at in an application or in a website. Those are provided by GUI frameworks. Before looking at the programming concepts which this GUI offers, first if we compare this conventional kind of programming and event-driven programming, and we look at the difference between them, then we see that in the conventional programming, it's a sequence of operation is determined by the program. As I told you before in the previous lecture as well, that in traditional kind of programming you write a code, and then compiler, what it does for you is that it runs the code line by line, and it does the functionality which is written in those lines. So it doesn't go out of the code which you have written, and it doesn't do any extra functionality for you if it's not written within the code. So what you want to happens when you want it. Wherever you have written it, wherever you have called the functions, it will be performed accordingly at that position. So, and of course in the conventional programming you can make use of libraries as well. Libraries were offered a long time ago in previous languages, and even in the obsolete languages there was the provision of using libraries, but it died out using libraries because libraries could make your system bloated, and it can take a lot of space in the memory. And libraries were even offered in C and C++ language if you have ever used it. So that is a conventional way of programming where you have got full control on the program. But in the event-driven programming, basically what you do is that you give the control to the framework. You tell them what kind of events you want in your system, where you want them, and you don't have to code those events. You just tell, or you just inform the framework that at a particular occasion or at the particular kind of event there should be some execution of a particular code. And for example, if you have put a button in your program, then you can write you can tell the framework to put the behavior behind that button, that if that button is pressed once, what kind of behavior it should the framework should run, and if the button is pressed twice, then what kind of event should be initiated, or if the button is pressed continuously and if you keep pressing it, then what kind of different features that could be invoked. So the sequence of operations is determined by the user's interaction with the application's interface. So on the interface you have got different kind of layouts and you have got different kind of features on the interface. So whenever you interact with those features, the events are automatically executed, and the events codes which you have mentioned or which is already written in the frameworks is executed automatically for you. Anything that can happen happens at any time, and it's not in a sequence. For example, in an interface you can press any button, you can click on the menu, you can click on the options which are given in the menu, you can click on hyperlinks at any time, and when you click it, that event will be invoked and that kind of behavior will run automatically. But if you look at the sequential programming and the old style of programming, you cannot do this. Okay, you have to run it in a sequence. You have to run the program in a sequence, and the sequence which you have mentioned in the code, only in that sequence your program will run, the system will behave in that way. So that event-driven programming has given a lot of flexibility to the application development nowadays, and it has also transformed the website applications as well. And nowadays you have got all these features, you have got all these buttons available on one application interface or a website interface, and whenever user interacts with any kind of feature in that interface, the corresponding behavior is run automatically and does the functionality for you. So event-driven programming was actually started when GUI features were introduced, and it simply is that you write the code behind different kind of interface constructs, and events are generated when you interact with them in any way. In the GUI design concepts, I would recommend you for the reading, I would recommend you should go online, or you should look up in the books principles of good GUI designs. There are so many books available on GUI design, or even in the Java programming books you can find GUI design topic as well. And then there is on the IBM website you can find design concepts. There is a lot of literature given. And there is HCI page, human computer interaction page. If you Google Saul Greenberg's HCI page, it has got all the libraries which are used in the GUI design, and it has got explanation about the features in GUI. And then there is you can also Google Tim's HCI notes. Well, that is also a programmer's web page, but it has got a very good tutorial on GUI design. So other than this, of course, you can find material on your own. You can consult some books, or you can go online and read some tutorials on GUI features or on the frameworks, design frameworks. So it's up to you where you could find the material, but you can look up the constructs which we are going to cover in this lecture. I'm going to give you a little bit explanation about them, but to get a good command on them, so you should read about them, and of course you should use them. You can write code in Eclipse or JBuilder or any framework, Java framework which you have downloaded, and try to write the code in it, try to play with it, and see what happens and what it does for you, and try to modify it, because it also allows you to modify the code written behind these constructs. Java GUI has got components. And if you compare Java GUI with Windows GUI or Unix GUI, then you see that the concept is same, but in the Java you call them components. The components do different kind of tasks for you. And if you are using Windows GUI, it has got controls. So basically components also have got controls, but there are different names in different kind of frameworks. Similarly, there is a Unix GUI available as well. In the Unix they are called widgets, and they do the same kind of stuff for you. So examples of different GUI programming concepts are like labels, buttons, checkboxes, radio buttons, text input boxes, pull down lists. So these are different kind of examples of these constructs which you can use in GUI. There are swing components as well. Swing provides you a library of components, and you can import swing in your Java program, and it can create labels for you, button for you, but they are called JLabel, JButtons in Java Swing. There are JCheckBoxes, RadioButtons, text fields, text areas, and combo boxes. So these are different kind of features of GUI which you can embed in your Java program. Let's look at the history of Java GUI. In the beginning, when JDK 1.0 was introduced, it has got AWT, abstract window toolkit, which used to provide you with all the GUI features, and it also had got library attached with it. You could use their methods, you could write the events behind it, and you could still use it. AWT is still in practice, but of course it has been replaced by Swing, because a Swing is basically a subclass of AWT. I'll tell you about Swing a little later. In AWT, you had to import the package java.awt or java.awt.event, and it contains heavyweight components using native GUI system elements, and it is used for applets until most browsers support JRE. So you also have to install JRE 1.2 to AWT to work, and because that JRE has got all these features at the in the background, which runs for these applets, and then you can use the applets of AWT. Okay, Swing, basically Swing is a subclass of AWT. It was introduced in JDK 1.2, and then in the later all the versions of JDK it is supported there, and it is also supported by Java 2, because AWT was in Java 1. Swing has got all the features which AWT has got. Because it's a subclass, so of course it can use all the features of AWT. But the difference between AWT and Swing is Swing has got lightweight components. Okay, they're not as heavy as they were in the AWT, so they put less pressure on the RAM, and you can do the RAM memory management easily with Swing libraries, and they do not rely on the native GUI or operating system. Its look and feel is also different of Swing components. They are identical on different platforms, and they can be customized. We will look at them when we will practice some of the Swing components during the labs, and I'll also give you some assignments to work on Swing components. And then you can see that I'll also give you some assignments to work on AWT and Swing, and then compare them, what kind of different features they have got. Of course, Swing is a newer technology, so it has got better components, lightweight components, but AWT was very robust technology in the beginning. It had got very efficient features for events and layouts, so people still use them for events and layouts. So if you look at the code of Swing, Swing is inherited from AWT. It is extending some of the features of AWT. Swing components in Java advanced GUI support, for example, drag and drop. So it provides you drag and drop facility. What is drag and drop? That it, for example, if you are making an application and you want to put radio button in it, or checkboxes or simple buttons, then it provides you with an interface which has got all these buttons and all these features which are provided by that specific framework. For example, it has got menu option, button option, scroll bar options. So you simply drag them and drop them in the edit area or in the text area, and what it will do is that it will automatically create the code behind those features. For example, if you put the button, then it will create the basic code of the button, and then it will allow you to put some events behind it, like if the button is pressed in a certain way, what kind of functionality it will perform. So drag and drop, it's very easy. And if you are designing an interface and if you want to put different frames in it, different buttons in it, and some fields, text fields, some input fields, or some dialog boxes, then you can simply drag and drop them and can customize the code which is automatically generated for you. You can switch between the windows, code windows, and the application window. And on the application window, you're gonna develop that interface. On the code window, you can customize the code in whatever way you want. And even if you don't write any code behind it, it will still run, and it will still generate that interface for you. The package which is used for this is javax.swing and javax.swing.event. And components are inherited from JComponent. JComponent is a Java component class which has got all the methods which are needed for components. Components are added to a top level container, JFrame, JDialog, or JApplet, and then you can inherit all the features which are written in those classes. Okay, how you run a Swing application? Basically, if you are using command line interface, then you simply write java-dswing.aa text is equal to true, and then my swing class. The option sets the system property swing.aa text to true to enable anti-aliasing for every J component. Now Java W runs a GUI without the console window. Okay, so you have to import Swing library as well. In the beginning, what you do is that you write import java.swing.static. Static is for that you are importing all the libraries which are attached to it and all the classes which are part of this. So, and you can also, my Swing class, you are making a new class to it, and that my Swing class is going to have all the libraries which are part of Swing. Now it totally depends on you that what kind of libraries you want to import, what kind of features you want to use. And mind you that in the previous lecture I mentioned that you can also override the methods which are written in Swing. So even if there is a code written for a specific kind of a button, which that code can write and that can create that button for you, you can go and override that button method, and you can customize it according to your own needs. Okay, for example, if you want your buttons to be horizontal, circular, whatever the way you want to make it look like, then you can go and change the code a little bit. Because it's open source, the library code is available with the framework. So, and you can also I would also recommend you to go and look at the hierarchy of those classes, how those classes are organized, and try to look at the methods which they have got and try to override them with different kind of feature. If it doesn't work for you, then you should read the tutorial, try to find that what is the code which is written to make a specific button or checkbox or a radio button, and then try to customize it according to your needs, or just play with it. That if you change a certain kind of line of code, that what kind of different change you can view in the button itself, and you can give it different colors as well. And of course the events functionality is given in the framework, like how you want that specific component to work. You have to declare a container and a component, and you have to add components to one or more container using a layout manager. Now what is a container? Container is basically a window in which you group different kind of components together. For example, the container could be one interface, or it could be one page, the home page of your application, and in the container you put specific components which are related to each other, or which perform a different kind of similar feature. So you put them as a group in certain container, and then you can also add you can also add more than one components or containers in your application as well. For example, if you are working on frames, you must have seen that in some certain applications or some certain websites there are multiple frames on their interfaces. Now those frames are actually containers, and they can contain multiple components in them, and then one group of components perform together. Okay, they are different from other group of components, and you can register event listeners with the components. Now event listeners are basically the observers. What they do is that they look at the button and they see that how that button is changing, like how that button is being pressed, how that button is being used, and if it is being navigated, that what kind of different functionality should be inserted. So event listeners' job is to observe any changes in the interface and do the and invoke the event which has been written by the programmer behind that change. For example, if you start writing something in the password box, now password box is an input box. Now you will see that when you start writing in the password box, it automatically converts it into static signs, means it is hiding what you are writing there. And if you write it in any other input box, it will write normally. So how that component or how that container knows that this is a password box or this is a normal, because you have mentioned it behind, and you have assigned different values to it, and you have assigned different event listeners to it. Now those event listeners behave accordingly. And also, you know, there are different kind of restrictions which you impose on these text boxes. For example, if a box is taking name, okay, or if the box is taking personal information, and it is taking your first name and last name, then the name cannot have any other kind of entry in it. For example, the name should have all the letters, and it should not have any other keyboard features in it other than letters. So if you try to do that, then it will let you know that you are adding something which is not meant to be entered in it. So that is part of the restrictions, is also part of the event listeners. They take care of it. They take care of it, that what kind of input is being given and what kind of action is being taken. And you also create event listener methods. Now registering event listener is the way of introducing event listener. That event listener, they will do is that they will work in the background, and they will look at what kind of changes are being made in the interface. But if you look at the event listener methods, they will contain the behavior which will be performed once an interface component changes, or once an interface component is interacted with the user. If user clicks on some kind of a window, that what feature is invoked and what kind of behavior will be run. Okay, so that is the difference between registering event listener and creating event listener methods. Now basic GUI programming concepts in Java, we have got some examples like jframedemo.java and jframedemo.tm.java. So basically these are the different containers which you add, and these are the classes which have got all the features of adding a listener to it or a listener's method. And the container is basically a screen, a window applet or window panel that groups and arranges GUI components, as I told you before. So if you have got a drag and drop facility in a framework, and it will provide you with all the components which are available which you can use. First you will make a container, and you can make multiple containers in one page, and then you will drag the components which you want in the container, and you just drop them in the container, and it will automatically, the code will be generated in the background, and then you can switch to that code window and look at the code, and then you can modify it, change it, customize it according to your application's requirement. And it arranges GUI components as well. It has got features like how you can arrange different components within a container, where you can put the different components. You can do your own, designing, and the way you want your whole page look like. It's up to you. And basically the component is an object with visual representation. It's basically part of a class. For example, if it is a button component, JButton, it is a part of a JButton class. So it is an object of JButton. So that object has got methods attached to it, because as you have already studied about objects and classes, so if the methods which one class has, and the object of that class can use all those methods and can call all those methods. So behind the button there is a JButton class, and this is basically a visual object. Okay, and you can play with this object as you play with other normal objects. You can call different kind of methods, you can override the methods, you can call the methods from parents classes as well. And swing containers examples are JFrame, JApplet, and JPanel. Now frame is another kind of a container. It will make frames for you. Frames are when you divide your page into different portions. For example, you must have seen such kind of website or such kind of application where you have got name is written on top of it, and then it has got a horizontal menu, and then you have got on the left corner you have got a vertical menu, and then at the bottom of that page you have again got horizontal menu. Now if you look at it, the menu style is different. So this is handled by frames. Now you have got 3 frames, or you have got 4 frames. You have divided your whole page into frames. You have divided into the top frame, a bottom frame, a left frame, or a center frame. In the center frame you have got the main area where you have got all the main information. In the bottom frame you have got different buttons or hyperlinks which provides information about that particular page. On the left menu or left frame has got left menu in it, and so the top frame has got top menu. So frames are basically division of a page. Okay, so if you want to divide your page, and if you want to put different components in those kind of pages, then you should use JFrame. Okay, you can import JFrame. You can look at the code of the JFrame as well, like what kind of different features it has got, and then you can call those features and use them in the frames. There is a JApplet as well. If you want to use applet in your program, or if you in your system, then you can import JApplet. You can call JApplet. And then there is a JPanel as well. Panel has got it's a different kind of container, and it contains different kind of components in it. So these are 3 examples of containers, and these containers can have different kind of components in them. And if you talk about AWT containers, they had frame, applets, and panels. The difference between AWT and swing is this J word attached with it, and it had. But of course, in the swing you have got variety of components. You have got a lot of extra added features in it, because swing is a newer version of GUI, so it has got more features in it, more functionalities in it, and a lot of different classes have been added to AWT, and But still, as I told you before, for event handling and for layouts, you still prefer AWT containers. Okay, in the event-driven programming, the Java approach, what you do is that a piece of code that is event handler is attached to a GUI component. So you write a piece of code which is attached to the GUI component. You either write it yourself, or the code which this framework does it for you, you just rely on that. Okay, an event handler is called when an event, for example a mouse click, is activated or fired. Means that when a mouse click is is done on a button or on a menu, that what kind of action should be taken. So that is written in the event handler, and that is written in the form of piece of code. Now that piece of code could be modified by you, because sometimes it is generated automatically by the framework, and if you just want to have that functionality, then you can go with that. But if you want to add something new, or you want to customize that event handler, then of course you can go behind the button and you can look at that code and add something new to it. The delegation event model in Java, basically what it does is that it processes an event and that is delegated to an object, the listener in the program. So the listeners are basically the delegations. The listeners are the piece of code that listens to the condition of a button or any component which is in your program, and then they do accordingly. So the delegation event model basically takes care of that. It delegates the changes in the behavior of that component, and it delegates that changes to the listener, and then listeners invokes event handler, and event handler does job for you. In the event-driven programming in Java, event source a GUI component that generates, fires an event. So the event source is that GUI component. The event is a user interaction. For example, a click on the button, or just moving your button, or the right click on the button, or the right click in any text box. Okay, you have got two clicks on the mouse, right and left, and there are different features attached to both clicks. So the event will be the interaction of the user, what kind of features that user is looking for. And event listener is an object that has encapsulated event handler to react to an event. Okay, so event listeners will keep looking at that component. They are basically observers. If you have studied design patterns, which we are going to cover in the next lectures anyway, that if in design patterns you see that observer pattern is used. The purpose of observer pattern is that you have got two classes. One is the observee and one is the observer. So observer, what it does is that it looks at the observee and it looks at it for any changes. So if there is any change, the observer takes notice of that change and does some kind of a job according to that change. So event listener are kind of those observer classes. So their job is to keep looking at the component and keep monitoring the changes which are going in that component, and then they invoke the kind of reaction which you have intended in the beginning when you wrote the code. Okay, event handling in Java, the delegation event model, basically a GUI element delegates the processing of an event to another piece of code, that's an event handler. So there is a GUI element, the code of GUI element is written and it is automatically inserted behind a component. That GUI element delegates the processing of an event to another piece of code, that is event handler. So if there is any changes in the event, that is delegated to the event handler, and event handler takes the action accordingly. The event source generates or fires an event and sends it to the event listener. So there is an event source. Event source is basically that component. So if any change it has to happen, that will happen in that component, and the component could be changed. It could be changed with the help of a keyboard. For example, if there is a text box, then it could be changed with the help of a keyboard. You start typing something in it, and the event listener will notice that there is some kind of input from the keyboard to that kind of dialog box, and then the action will be taken according to that. And in the case of buttons or menus, then a mouse click is some kind of a source. Okay, after this the event source, let's talk about event handling in Java. The delegation event model, if you look at it, event listener must be registered with an event source in order to receive notification. Now, of course, event listener cannot be written separately or independently. They must be attached with an event source. So that attachment is called registration. So you have to register every component with an event listener. So we're going to do it when we will work in the labs or when we'll work on the assignments. So what you do is that registration process is that you create those event listener, or sometimes design frameworks, they create listeners for you in the background. And if listeners are all, they are in the shape of methods, okay? So these methods are attached with the component object which you have created. So their registration is performed. How do you do it? That you write a piece of code that what event source is connected with a specific event listener. For example, if you are connecting menu with the listener, then the listener will only observe that menu. If you are connecting a dialog box or an input box or a buttons or a radio buttons or a check button, you know, the listeners will only observe the specific components which is registered with them. So example is, for example, JButton demo.java and JButton demo 2. So if you have got two JButtons and you can attach or you can register event listener to these two buttons. So that listener will only keep an eye on these buttons, and as soon as there is any modification, any change or any interaction by the user, then they will inform that to the event handler, and event handler will do the rest. Okay, this is registration and event listener. Write a class that implements an listener interface. So what you do is you write the name of the event and the listener, and then interface, you implement it with that listener interface. So this way you are creating an instance of that class that is an event listener, and you are registering the listener with a GUI component. So you have to register it. How you register it? That add event name and listener. So this way you are adding the listener name to it, and so the listener will be attached with it through this piece of code, and it will keep looking at that and in that component, and it will do accordingly. A listener interface has a list of standard event handlers, that is methods. So I told you before, event handlers are in form of methods. So a listener interface has got all the list of standard event handlers. So you can look at the listener interface. I told you that in the libraries a list of all these interfaces is given anyway, and the code which is written in the interfaces is also given. So you can go in there and you can look at all the list, all the methods which are provided by the interface, and then try to find the listener which is suitable for the component. Okay, and then API documentation is also given, in which you can find more material about java.awt.event, the event classes, listener interfaces, and adapter classes as well. In the java.awt.event, you will find the detail about all the events which are handled by that specific framework. In those events, basically, the events could be in any form, okay? So I told you that if you are interacting with the mouse, then it has got 3 or 4 kind of different events. For example, a right click could be initiated by the user, there could be left click, or there could be dragging of the mouse. So these kind of different actions could be performed. So according to that, there are different methods which are given in it. Now those methods are standard methods. Okay, they have got specific talks which is taken by most of the by the programmers. But if you want to customize them, it's totally up to you. Okay, you can override them, you can customize them, you can add some behavior, or you can go with the by default behavior which is given by the framework. Then there are event classes. All the classes which are attached with the events are also given. You should read them and try to look at their code, that what kind of different functionalities they are performing. And event classes obviously have got event methods as well, which have got event listener methods and delegation methods and registrations methods. You should look at these listener methods and try to comprehend the code which is written in the methods, how that code is working. Now you can of course modify it. We'll look at it and when we are working in the labs, that how you can modify the code. But just for your information, you can play with it. If you modify one piece of code, what that event listener is going to do for you, and if you insert some different code in it, then how that action is modified and how that the behavior which that component is doing is modified. There are listener interfaces. There are many kind of listener interfaces. You can implement the class which you are implementing from any of these interfaces, and you can have different kind of functionalities if you implement different interfaces. Then there are adapter classes. Adapter classes, what they do for you is that they have got adaptation from other classes. I'll show you some example little later. What these do is that they take adaptation and behavior from other classes and they implement them. So you simply extend these classes, or you simply become a subclass of this class and you can adopt in these classes according to your own need. Event handling in Java, different ways of coding the event listener, use of another top level class, JButton demo, and anonymous inner classes as well. In the event handling, you can use top level class. The top level class is always JButton demo. In the JButton, all the code that is related to button is written. In the JFrame, the frame related code is written. So what you do is that you take you take the code of the highest class, which is the parent class, and you insert it in your own class according to your own need. But there are some anonymous inner classes as well. For example, JButton demo 2, JFrame demo, and JFrame demo 2, and the use of an adapter class, JFrame demo 3. Now anonymous inner classes, if you remember, I told you that you can write nested classes or inner classes. Inner classes purpose is that if within the premise of one class you are going to perform another functionality, then you can add in an inner class. So in the inner classes, I told you like nested classes can be written in the Java, and within a class, if you need a different functionality, so you don't have to write a different class altogether. What you can do is that within the body of a class you can write another class, or you could write it with the body of a method as well, and in method they becomes anonymous. So normally the classes which are written within the method's body are called anonymous inner classes. Some of the examples here are JButton demo 2, JFrame demo, and JFrame demo 2. So these are written within the methods of JFrame. Now why do you need to write these kind of classes? Sometimes it is intended that a certain type of feature should be written in form of a class. For example, we saw enumerations in the last lectures. Enumerations are a set of similar elements, and you put them together in a class form. Now that class, it doesn't make any sense if we put it outside any other class, or if we make it an independent class, because it just contains similar items, and those items are going to be used in a class anyway. So if there is a situation like this, and if you want to make an enumeration class, then you should always put it within the body of a class where it is going to be used. And if that enumeration is intended to be used within a particular method, then you should put that enumeration within that body of that method. That will make it anonymous. Why anonymous? Because if you studied automatic variables or local variables, I told you the variables which are mentioned within the method, then their life is only within the scope of that method. So if that method is called, their life starts, and when that method exits, their life ends. So is the case with these classes. Their life is within the life of that method, and their scope lies within the scope of that method. So they are not accessible from other methods, they are not accessible from other classes, and they become anonymous. So it is intended sometimes when you are making frames, when you are making buttons, and so you want to generate that kind of buttons which are part of some kind of a method, then you put them in the inner methods, and you make them anonymous. An anonymous thing is also beneficial sometimes when you are implementing data hiding, and you don't want other classes to look at that class, or you don't want other methods to access that method. For example, if you have got that enumeration, and that enumeration is supposed to be used within one method only, then there is no point of putting it globally, or no point of putting it within the body of class, because by doing that, what you are actually doing is that you are giving access to all the methods to use that, and those methods don't need it, because it is only used, or it is only required within one particular method. So it is always advised that you should keep it in with that method. You can make it an anonymous inner class, and then the scope will be within that method, and that inner class will be only used within that particular method. So is the case with the adapter classes. Now this is not the position to make you understand these adapter classes. Once we will start solving those lab assignments, then we'll look at some examples of adapter classes. JFrame demo tm2.java uses named inner classes and shows how to consolidate window closing from two different events. Now, when there is a situation when you have implemented some windows and you want them to be closed from two different events. For example, sometimes you must have seen any dialog box or any window, they have got a cross option at the at the top on the right corner, and then you also have got another button which says cancel now, or OK button. When you press OK, the window disappears automatically. If you click that cross button, it disappears, or if you press close button, it closes. So now there are three different events which are actually closing the window. So it means that your window has got three different events. Okay, so if there is that kind of a situation, you can introduce some inner classes to close that window, and those inner classes will take care of that event handling which actually initiates the closing of the window. So these are some of the examples of the situation which can arise when you need named inner classes rather than anonymous inner classes. Okay, handling of mouse events. In the mouse listener, you have got these methods which are provided by mouse listener class. Mouse pressed, mouse clicked, mouse released, mouse entered, and mouse exited. So these all have got code written behind it, which is by default code which comes with these methods, but of course you can change it according to your need. Mouse pressed means that once the mouse is pressed, what action should be taken, and if it is clicked, what action should be taken. If it is released, sometimes you also need some behavior to be run when the mouse is released if it is pressed for a long time. Mouse entered. Now if the mouse mouse enters within a particular window or in a text box, then what should be done? Like if you enter in a text box, then it allows you to type in it. So that entry is mouse entered, and that entry is initiated by that mouse entered method. Similarly, mouse exited. If you exit the mouse, and then if there is any behavior you want to happen, then you can write it, and you can override this method anytime, because this is part of mouse listener. And if you're extending mouse listener, then you can override any of these methods. Mouse motion listener, there is another one which has got methods dragged method and moved method. So if you are dragging mouse, and there is a different functionality that could be performed, or if you are just moving the mouse, then what should happen? Sometimes different features are required when you are just moving the mouse around. Okay, and if you're dragging it, then resizability could be performed. The window could be its size could be changed. It could be shortened, or you can make it a bigger window with the just drag of a mouse. Similarly, you have got classes for adapter, mouse adapters as well. One of them is mouse adapter, and the other is mouse motion adapter. So these are responsible for adapter classes. As I told you before, that in coming lectures we'll talk about adapter classes, and there are some related adapter classes with mouse as well. The examples are mouse demo.java. Multiple event sources. There could be multiple event sources as well. For example, action applet2.java and .html. One listener for multiple event sources, and GUI and graphic programming as well. Well, now you have got this link. If you go on this link, you can find a lot of material about applet demo. And in the multiple event sources, what happens is that rather than one source, you have got multiple sources, like multiple components are being observed by one listener. Okay, there could be one observer who is keeping an eye on multiple components, like if there are multiple checkboxes. Now this is a prime example of multiple sources. Like checkboxes, you have got 4 options, and they've got checkboxes, and so it will look at all the boxes, and it will keep track of the modification in all boxes. For example, if the checkboxes are giving you ability to check more than one, then it will take input from more than one checked boxes. But if it only allows only one checkbox, then it will disable the other inputs from other boxes, and it will take only from the checked one. So this way, you can handle multiple components with one listener, and that one listener can send the information, delegate the information to the event handler, and then according to that event, the event handler will run its behavior. Okay, a lot of information is given on GUI and graphics programming. You can check this source. So this was our today's lecture. So that was the last topic. Now let me revise today's lecture. Today we studied about GUI and graphics. GUI is basically graphical user interface. These are design frameworks which are offered by Java. You can write different kind of codes of application, but the main features they offer is the components which you can add to your system. Now there are GUI interfaces which provide you the ability to drag and drop components on your website. I also told you about containers, which contain multiple components which are similar in nature. You can also have a frame container as well, which divides your page into different frames. You can lay out components differently in different frames, and you have got event listeners which are attached with the components. So what is the functionality of event listener is they are kind of observers which keep eye on the components, and they take inputs from the components. So if there is any interaction by the user, it could be in any way, it could be interaction through mouse or a keyboard or any other device which are attached with the system. So they observe the component and they look at the changes which are made and what kind of changes are made. For example, if the input is through mouse, then they look at it that what kind of event has been performed by the mouse, what kind of interaction the user has performed using the mouse, and according to that a delegation is sent to the event handler, and event handler takes action accordingly. Then I told you about delegates and event sources. I also told you there could be multiple event sources as well. Like one listener can listen to multiple components, and they can send multiple information. They can take inputs from multiple components, and then they can inform event handlers, and event handlers can take action according to that. So this was the lecture about GUI and graphics. We have not yet started writing the code in GUI. I would recommend you to work on Eclipse and try to search the links I have given you. You can find a lot of code there and a lot of material about these components. And what you can do is you can simply copy the code from these sources and paste it in Eclipse and try to run it and try to see what it does for you. Or what you can do is that in that Eclipse framework, drag and drop facility is also given. You can play with that drag and drop. You can add components onto the screen. You can add some containers onto the interface and try to write the event listeners and write event handlers as well, and try to customize them. Try to put some more code to it and see what happens. For example, you can add one window, one display window in your interface and one button in your interface, and then when that button is pressed, then hello world appears in the window. So this is a very simple one. What you can do is that in event handler you can simply write the code to display a hello world, but that event handler should be registered with that particular button. So I'm going to give you some coursework to do as well on this GUI and graphics. So once you do that coursework, then you will become more comfortable in using them, and then you will understand these concepts better as well. So this concludes our lecture today. In the next lecture we will come with a different topic. तो आज का लेक्चर यहीं पे ख़त्म होता है. मुझे इजाज़त दीजिए. नए लेक्चर में नए टॉपिक के साथ मिलेंगे. तब तक के लिए अल्लाह हाफ़िज़.